Okay, I'm gonna find a place where I can put myself on the screen and not obscure anything. I guess down there will work. So here is a little video version of my first installation of the physics textbook, what we add to this. Um, so this is beginning on October 22nd. Um, Probably some of you may have added more than I will add today, and that's fine. Um, all I added was, first we did a reading about scalars and vectors and the difference between speed and velocity. And then I asked everybody, well, what are some of the terms that came up that we could use as vocabulary terms for our notebook here? So some of the terms, of course, that came up are speed, oops, velocity, um, vector, and scalar. Um, Now, we need to distinguish between speed and velocity, and there's a fairly straightforward difference. Speed, you kind of have a sense of speed. It's something about motion. We're in motion. So speed is just simply how fast an object is going. Velocity, on the other hand, is a little bit more sophisticated. It does kind of mean speed, and certainly in normal English, we can kind of use them interchangeably, but it's really got a speed combined with some directionality, some direction. So what we might say is the rate at which something changes position in a particular direction, or the speed of an object in a particular direction. So velocity is not just speed, but it needs direction to it. I'm not just going 5 miles an hour, I'm going 5 miles an hour straight up. And that brings us to the difference between a vector and a scalar. A vector is a quantity that has a direction as well as a magnitude. A quantity that has a direction as well as a magnitude. And of course, that begs the question of what is a magnitude? Well, magnitude is basically a size or a value. So a vector, a quantity that has a direction as well as a magnitude. Like I said, the magnitude of my speed might be 5 miles an hour and the direction straight up. So, and that leaves us with a scalar, which is a quantity fully described by magnitude. Quantity fully described by magnitude. And again, size or value. So temperature is a great example of a scalar quantity. It's 57 degrees Fahrenheit. There's no direction. We are fully describing the temperature out there by its magnitude. So these are some of the first terms we've added. So I'm going to stop here. I'm going to keep adding things to this notebook.